Hi, session number 11 of EaganMatrix programming for the Haken Continuum. We're now at a point where we can really start to have some fun and think about creating our own presets of various sorts. So let's today do something pretty simple. Let's just use oscillators, and maybe we'll throw in a blend function since we haven't talked about that very much. And, well, let's think about what kind of sound we might want to create here. If I'm only going to use oscillators, an easy kind of thing I can do is try and create an organ sound. So let's do that. I'll set my oscillators up. Let me use 5 integrated oscillators. And if we think a little bit about organ pipes, without going into any physics of any depth, the two basic things we need to remember is that an organ pipe that's an open pipe will have a full range of harmonics, but an organ pipe that's closed at one end, the closed pipe, only has odd harmonic content. So knowing those two things, we can take a sine wave and simulate our harmonic content through some multiplication, and hopefully we'll get a sound that is close to an organ. So let's do that. We're going to track everything to the fingerboard, so all of our oscillators are going to be controlled by X, right? So whatever the frequency of the oscillator. So every oscillator, we're going to set its frequency to whatever I play on the fingerboard, all 5 of them. Right? And I'm going to route all 5 oscillators to the output. 1, 2, 3, 4, and 5. We'll just use the standard Z function, standard pressure, default pressure function. Now I've got so many things routed out there that maybe as a multiplier I'll multiply this by 0.5 so I don't overload anything. And because now I haven't done anything to any of the oscillators, they're all the same, I basically just have the same sine tone routed out 5 times, which is not of much interest. It'll sound like a big sine tone. Well, I guess there are some organs that have a kind of a siney kind of sound, but that's not really what we're after. So let's ask ourselves, all right, let's multiply out our harmonic. If this is the fundamental, let's consider the first oscillator the fundamental frequency. So the second harmonic, or first overtone, whichever you want to think of, let's use that. Second harmonic is the octave, and the third harmonic can be gotten by multiplying by 3 and 4. And maybe what I'll do is, instead of the fifth one, let's take this last one and we'll add the subharmonic in. We'll add an octave beneath the fundamental by multiplying that by 0.5. All right, now we should have something that sounds a little bit different than just that sine tone that we just used. All right, that sounds pretty much like an organ. But my fingerboard is doing what it's supposed to, giving me that nice portamento between notes, but an organ doesn't do that. So even though it's wonderful to be able to play an organ on the fingerboard with all that variable pitch, that's keeping it from sounding kind of organ-like in some ways. So what can I do to make my pitches quantized as they would be on an organ? Well, can't do it with just the standard X function. Let's create a formula, and we'll simulate the X function by setting it to that. So that pretty much does what X does up top. But now here, this Q, this quantize thing that can be set, instead of turning it off, I'm going to quantize to the semitone. All right? And now I can, instead of using X, I can stick A in on each one of these things. And now when I play the fingerboard, when I go from note to note, it's quantized. And it's nice I can use the pressure for volume, so I don't need to add a volume pedal. The fingerboard will do that nicely for me. Hey, that's pretty cool. Easy way to get an open pipe kind of sound. All right, let's do the closed pipe. And we'll just use the odd multiplications now. So the fundamental being the first harmonic. So we'll put the third, the fifth, the seventh. Let's go all the way up to the ninth on this one. And this should sound different. We're already still quantized because our A is here. You can hear if I just I can get that kind of rotating motion. That's nice as the trill here, but if I'm not careful, it'll sound like it's cracking almost. So that's a playing technique issue, but my organ sounds pretty darn good. So I have two different kinds of organ sounds now. And what I'd like to do is write a program that lets me easily go between these two sounds. Well, how am I going to do that? And not only that, by the way, but this is a little unorgan-like to the extent that all of the harmonics are routed out at the same amplitude, and that's not really how the organ sounds or any sound that uses natural harmonics kind of evolves. The harmonic content should be variable in some way. I can bring up my little spectral analyzer here, and we can play note. You can see all those harmonics there are at the same amplitude. So I also would like a way that I can vary the amplitude of those harmonics as well as shifting back and forth between my two kind of organ sounds that I've created here. So to keep this from going on too long today, I've just brought up a patch that I created that's going to do what we want. Let's take a little bit of a look here, and it looks pretty much like the one we just created with a lot of the presets, but now we have pretty much a user-defined formula used everywhere except for the routing out of the fundamental, which I kept the default Z formula for that. So let's just go through and look at a few of the things that we've done here to make this more configurable and allow me to get a greater variety of organ sounds out. Also in conjunction when using a couple pedals for different functions. So instead of all these Z's you can see here, I've created separate formulas. And I've attached, let's just look at D for example, and for each one of these formulas I've attached it to a barrel. And each one I use a constant going from 0 to 1 multiplied times the z pressure function, which I've taken, instead of using this squared function, I just made it linear. So I find that I can hear the effect of what I'm doing here better that way. And from a pressure standpoint, it's fine, since organ doesn't typically have a pressure sensitive function on it to begin with. So so basically what this is doing is, as my barrel is adjusted, it's going to multiply whatever my output is times the constant value at that point, which basically will let me adjust the volume of each one of my oscillators, which, as we said before, each one is going to be a different overtone in what we're doing. So this will allow me to get some easy way of changing the relative amplitudes of these harmonics, almost like kind of a drawer bar on an organ. What I'll do first is I'll just set them all to max, which kind of simulates what we did in the first example. All right, so that's all that's going on there. These are just volume multipliers on these barrels, which in turn are controlling the oscillator outputs. I multiplied the output here times a constant. Here I set it to 0.75. I could set that to a little less. It all depends on whether I think I'm saturating my sound. Of course, another thing I can do is turn the gain down. But again, nothing much complicated about that. The C function on each oscillator is the same function we used before. I used my own X formula so that I could set each one to the quantized to a semitone value. Instead of just using a sine tone, what I did is I created another formula, A, right, that is attached to the second gen, that's going to control my waveform. Right? And that I attached here, you'll see, to the continuous pedal, so that when I use my pedal, that waveform will change from 0, which is a sine tone, to about 0.8, which is its that almost past sawtooth kind of sound. But as you'll hear, the way this changes the sound is not as dramatic as going from a sine tone to a sawtooth wave. What it really will do is it will increase the harmonic complexity of my sound, because of the introduction of a lot more harmonic content as you move towards the triangle wave. All right, and the sawtooth wave. So that's a pretty simple function. That's just going to control, and it's controlling all of them together. So I pretty much am controlling all my oscillators as a group. One reason is I've run out of barrels and gens. Now an organ has all those stops that you can use to manipulate your sounds. I almost wish that I had 2 or 3 or 4 times the number of barrels here, so I can set up all these stops and do some really nasty organ programming. But for what we have here, it's going to be fine. All right, now the last thing that I did, and the important gotcha moment for this sound, is I needed to try and figure out a way, how am I going to move my sound from that open pipe set of values we had to the closed pipe set. And as it turns out, the blend function is a perfect thing to use here. So let's take a look at what I did. It's the same for each one, so let's just take a look at K. So basically, down here on the right hand side, you have this blend option function. There's a primary value. In this case, it's set to primary, value of 2. And then you'll set a secondary value, which lets you reset all your formulas to different values. But I'm only really using the constant, the W value here. So in this case, the secondary value is the 3. Because if you remember, I set my values to, with the open, 2, 3, 4, and 0.5 for that subfundamental. And I set them for the close to 3, 5, 7, and 9. So if we go through and look at our values, K on the primary is 2, on the secondary is 3, L on the primary is 3, on the secondary is 5, and so forth. M on the primary is 4, on the secondary is 7, and N on the primary is my 0.5, and on the secondary it should be 9. And it is. All right. Now how do I get the blend to work? Now I can blend on different things. I can blend on a formula. I can blend on the value of a barrel, but they're all used. So I can blend also on one of the gens. So I have one gen free. I'm going to use my first gen as the blending function. And what this is going to do is simply, as I go from 0 on my gen to max, the firmware is going to take the value and go from whatever I had, in this case 3, it's going to, as I move my dial to the right, it's going to make that move to whatever the secondary value is in this case. It was going to go from 2 as the primary to 3. Not much, 2 to 3, but on this last one, it's going to go from the primary of 0.5 to the secondary of 0.9 as I move that, that dial. Unfortunately, I have a bit of a problem here. So let's set everything up, and everything's set to 0. And you'll see what my problem is. If I play something, there's my open sound. And let me go all to the max to get my blend sound for the closed sound. But in between here, I'm going to have fractional values, and what is that going to do to my harmonic content? It's going to create all kind of crazy sounds for me, modulated kind of sounds, which now you can get some very interesting organ sounds with, you know, combinations of harmonics, and maybe you could use that for that. But I thought, well, I can always manually turn the dial to do that, but let me be a little more creative. Let me make it sound more like an organ that I'm changing a stop sound suddenly. So what I can do, instead of doing this continuously, I can put a switch pedal on it, and that's exactly what I did. I took my a switch pedal that I have, and I attached that to Gen 1. Now the switch pedal is going to make me go from 0 to 1. So when I press it, it's going to go instantly from 0 to the value of 127, and well, that's just going to map me to my two different sounds. So I can play a sound. Hey, that's pretty nice. So I can easily go back and forth between the two kind of stops, if you want to think of it that way, that I've created here. And the only other thing that I might want to do with my sound to make it a little more interesting is play around with the amplitude values here. So for example, if I just play my bass sound, oops, let's just go to my spectral analyzer. All right, I can take that and do something like remove a couple of the harmonics, and we should see when I play now. Here we go. You can see some of them are going away. unfortunately, this thing is set up so that my voice, as you can see, is kind of getting in the way a little bit. But I think you get the idea. It's easy for me to now play around with these things and get, a little different kind of a sound going out. You can see if I sit just on the edge of the quantized value there, doesn't sound all that good. So you really have to learn how to play the fingerboard all over again to be able to deal with everything being quantized. That is pretty much it for this sound. I don't want to go on too long. It just kind of show you how doing something very simple can get you some very nice sounds without really doing much. Oh, the only other thing that we want to look at is the waveform function that I've created here, and that waveform I've attached to the continuous pedal. So let me just set everything down. You can hear that if I play a note and then use my continuous pedal to change the waveform, I don't want to change it when I'm playing, or I'll get that shifting sound. Hey, I think that I can use this organ sound to my advantage, and it allows me great opportunity to add another patch to my arsenal. Oh, and you can see, by the way, something just to end. If I take my sound back to the sine wave for everything, you can see that the harmonic content there is pretty much set on the overtones that I've programmed. But when I change that waveform to something more complex, you're going to see the harmonic structure really get very complex. Because those sawtooth waves create so many overtones. And even though the sound still sounds like an organ to you, I mean, you can get such fine changes by slowly changing that S function on the oscillators, so that in effect I've got a whole range of organ sounds here without doing very much programming at all. So there we go. We started with an empty canvas and we created an organ. Pretty cool. So till the next time.